Hello friends, welcome to Rajesh Data Engineering. In this video, I'm going to talk about one of the performance optimization concept in Databricks development, that is bucketing. What is bucketing? Bucketing is nothing but splitting large data set into multiple buckets based on certain key. Actually, hash value would be generated on the key column. Based on that, the data would be sorted and it would be put into particular bucket. Then when we are performing Y transformation on the bucketed data, it will improve the performance. How it improves the performance? In Databricks Y transformations, when we have to apply certain transformation, then it will go through multiple phases such as shuffling the data and sorting. Shuffling and sorting, these are the very costly operation in Spark development. Let's say we are joining to data frame. Then what happens internally is sort merge join. I have already posted one video about sort merge join. In case you haven't watched that and you want to understand bucketing, then I highly recommend to watch sort merge join because this is one of the important concept to understand bucketing. So when we have to join two data frames, then basically it is done through sort merge join. In the sort merge join, there are three phases. In the first phase, data would be shuffled across executors or across worker nodes. Then the sorting phase will happen. On top of shuffle data, sorting will happen based on certain key. Then finally, merge operation will happen on the sorted and shuffled data. Then merge can efficiently join two data sets. This is happening under hood of sort merge join. So as I told earlier, in Spark development, shuffling and sorting both are very costly operation. So let's say we are doing join on data frame and many actions are depending on that transformation. We all are aware of lazy evaluation in Spark architecture. As per Spark architecture, it works on lazy evaluation, which means any transformation will not be executed immediately. Whenever we call certain action, then the dependent transformations would be executed one by one. Finally, action would be executed. Let's say we have a join that is nothing but a transformation, Y transformation. Then there are several actions are depending on this join. So when we are calling those several actions, each and every time, as per lazy evaluation, this join will be evaluated, which means each and every time this sorting and shuffling will happen. So this is costly operation and also it's happening multiple times. So it will hit the performance. In order to avoid that, what we can do, basically, we can shuffle the data and sort it once and store it in storage. Then in that way, we are going to pre-shuffle and pre-sort the data and store it in storage location. Then in the subsequent process, how many actions we are going to call, how many times we have to perform a join, then there won't be any shuffle or sort because the data is already pre-shuffled and pre-sorted. So this is how the entire transformation, the entire execution will be benefited. I hope you understood. So I will take you through some coding demo to understand that. Before getting into coding demo, I would also give some differences between partition by and bucket by. People used to confuse these two performance optimization techniques. So I want to give some clarity on that as well before getting into demo. Let's say we are having this data set. Okay, this is one of the data frame. This is having ID, name, country. ID is primary key, so there cannot be duplicate. All are unique values. Coming to country, we can see three distinct countries. USA, there are two records. One is 100 and one is 700. And coming to UK, there are three records. And coming to Australia, there are two records. Okay, this is our data set. So let's say I have to partition by country. Then when I apply partition, based on the country, then this is the output I'm going to get. For US, one partition will be created by keeping two records. For UK, there would be three records. For Australia, there are two records. Now, if I'm going to apply partition on ID, what would happen? Basically, in the partition, okay, whenever we are creating partition on particular column, so it is going to create one folder for each unique partition key. So in this case, it is going to create three folders. Okay, it would contain one folder for UK, another folder for US, another folder for Australia. Under that, it is going to create multiple partition files. And let's say in this case, we are having only 2 records, but let us assume it is going to have billions of records, or we can assume it's going to have 1 GB data. Then which means by default the block size is 128 megabytes. For 1 GB of data, it would split. It will create 8 partition. So it will create part 1, part 2, and it is going to create 8 partition. So this is how partition works. So in some case, let's say you are having 2 unique keys. One key is having billions of records, another key is having only 1 record. Even in that case, it is going to create one separate folder for that 1 record also. Within that, it will create one partition file. So this is how partition works. So within one particular partition folder, we can see data only for that particular partition key. It cannot mix. Under UK, we cannot have data for USA or Australia. So this is how it works. So partition is suitable when we have to split the data. We have to partition the data based on certain key where that column is having low cardinality, which means we are having only less number of unique keys. That is the suitable use case. In this case, in this data set, it is going to create three folders. But at the same time, in case we have to split the data based on ID, then what happens is it is going to create 7 partitions, because we are having 7 unique values. So it's going to create 7 folders. Under that, it will create partition files by containing 1 records. So that is not suitable, because in this example it's only 7 record, but in the real time we will have millions or billions of records. Then it is going to create millions or billions of separate folders. So that is also going to be costly operation. So partition by, that is always suitable only for the column, only the situation where we have to split based on certain column which is having low cardinality. If the column is containing high cardinality, we are better to go with bucket by. In bucket by, basically it is not considering one particular key. It is considering the range of the key. For example, for the same data, I have to apply bucket by based on ID column, and also we have to mention how many buckets should be created. Then what happens is for the same data, I'm going to tell you create buckets based on ID column, and we have to give number of buckets. I'm going to give 3. Then what happens is it is going to split the data in this fashion. So basically the first 3 records it is going to create one partition. It's not first 3 records. Basically the column on which we have to create bucket by, then hash key will be created for each key. For example, there would be hash value created for this 100, even for 200, for all the values. Then based on that hash key value, it will decide which record should be part of which partition. So in this example I have given, the first 3 records are going to one bucket, then the next 2 records are going to another bucket, and the last 2 records are going to another bucket. So this is actually it is shuffling the data. Then also it is sorting the data based on that hash key. It is keeping the relevant data based on the hash key. It is keeping relevant data into buckets, and also it is not going to create separate folders for each bucket like a partition. So here there will be only one folder. It's going to create only one folder. Under that one folder, it's going to only one folder. Under that, it is going to keep 3 files, 1, 2, 3. So this is how it works. And also one more thing, whenever we are combining partition by and bucket by, let's say we are having 10 partitions, then which means we would have 10 different folders, and we are applying partition based on a column. Then what happens is let's say I'm going to give 3 number of partition. Then what happens is for each partition, okay, each partition folder, it is going to create 3 buckets. Then for each partition, it will create 3 bucket file, which means if you are having 10 partitions and you are creating 3 buckets, then it means it's going to create 30 files. This is also important to understand. This is how bucketing and partitioning works. I hope you are clear with the difference between partitioning and bucket by. Now let's get started with the demo for bucket. I have logged into my Databricks environment and my cluster is up and running. So first step, I want to check if bucketing is enabled for my workspace for this Spark session. So basically, by default, bucketing would be enabled. So when I'm going to execute this piece of logic, it is going to return true, because by default, bucketing would be enabled. So let me execute this one. Yes, it's returning true, which means bucketing is enabled. Then the next piece of logic, I'm going to create sample data set for our demo. For our demo, basically I want to create just 10,000 records. So I'm going to create some dummy data using range function. So it will contain one key column, pk, primary key, another one is attribute. So let me execute this step, then it is going to show the data also. This is our data. So basically I have given, the value should start from 1 and it can go up to 10,000. There should be 10,000 number of values. Then the the interval, okay, between one value to another value, it should be 1, increment by 1. Then I'm telling how many partitions we have to create within Spark memory. So I am telling 10 partitions should be created, which means there would be 10 partition within Spark memory. If I'm going to write this into some storage, it will create 10 separate files for this output. This is the concept. Okay. Then in my next step, I'm going to write the same, this data as I'm going to create two tables. It's a managed table using save as table. Now I'm going to create one non-bucketed table. So here I'm not going to apply any bucketing technique. So let me execute this one. So the execution is successful. It would have created a non-bucketed table in my database. So here I can see. At the same time, if I get into the location where it has stored, by default, Spark would store the data into this folder, user, hive, warehouse. Then under that, non-bucketed table. This is my table. So if I look at that, I can see 10 different files. Because now I have created 10 partition. As a result, it has created 10 different partition files. Okay, now I want to apply bucket by for the same data, and I'm going to create bucketed table. So for that, I have to use the keyword bucket by. Within the bucket by, as per the syntax, I need to give how many buckets I need to create and how many based on which key I need to generate as key, based on which key we need to sort the data. So this is what I have to give. This is the syntax. Okay, let me execute this bucketed table. As I told earlier, the data frame is already partitioned by 10. On top of that, I'm giving bucket by 10. Basically it will create 10 multiplied by 10. It is going to create 100 data files, partition files. Let me execute this. The execution is successful. Let me check the database. It would have created bucketed table as well. Now there are two tables. Now let me go to DBFS location. This is my bucketed table. Within that, here you can see there are many number of files. Actually, there should be 100 files. So for each partition, it has created 10 buckets. Overall, we are having 10 partitions. So 10 buckets per partition would be equivalent to 100 partitions. Okay, now we have created two tables. One is non-bucketed, where we haven't created any buckets under partition. Okay, only there are 10 partition files. Coming to the next one, we have created a bucket. So basically under each partition, we have created 10 buckets. Now what I am going to do is, now I am going to perform some wide transformation, which would require data shuffling across executors. So for that, for this demo, I'm going to create two data frame based on the bucketed table and two data frame on the non-bucketed table. So here it's the same data set. Okay, for for this demo, I could not I don't have any other data set, so I'm going to use the same data set, and on the same data set, I'm going to create 4 different data frames. But in your real-time scenario, you might have different data for joining. Maybe one fact and dimension, or maybe fact to fact. It could be anything. But in this scenario, it's the same table, same data, but one table we have created bucket 1, another one is non-bucketed. So I am creating two data frame, df1 and df2, which are coming from bucketed table, and df3 and df4, it's coming from non-bucketed table. Let me execute this step. Data frame is created. Now I want to join df3 with df4. Both are non-bucketed. Then I want to see how it's internally working, how it is going to improve or hit the performance. So for that, what I'm going to do is I'm going to join df3 with the df4 based on the primary key column pk. Then by default it will be inner join. Then I'm going to see explain plan. And one more thing we need to note down here is by default in Spark, Now, if the joining, one of the data set is going to be less than 10 MB, then by default, it will be broadcast join by Spark. So I want to avoid that because, here it's really, very simple data set I'm using, but in your real-time scenario, you will have, much bigger data set. For that reason, now I'm going to show here, here we are not mentioning anything. I want to see the explain plan and I will show you. So in the explain plan, you can see it is using broadcast exchange. It's a broadcast giant. Anyway, it is going to improve the performance, but that is not our requirement here. So I'm going to disable this broadcast giant. So how I can disable? So for that I can use this auto broadcast giant threshold -1 I'm giving, so that it will disable. Let me execute this one. Right now I'm performing the same join and I want to display the data. I'm doing the same df3 and df4. Both are coming from non-bucketed table. This is the output. Here you can note on, here it has created 3 jobs. And within the job, let me click on the Spark UI. If you see, now in the Spark UI, we can see, it has created, stages. Here it is, it is scanning non-bucket table. Then after that, it is performing exchange. But actually we are using same data set. That's the reason it has created only one stage. Otherwise, if you are going to use 2 different data sets, then it would have created one more box also. That is for reading, scanning the other data set. Then once this non-bucketed table is scanned and also it has shuffled, which is nothing but exchange. Then finally it is being sorted. Okay, it's there are 2 data frames, both are getting sorted. Then it would be merged. This is how when it is operating inside, then finally it is getting the output for us. Just remember this DAG, then later we will see for different combinations to understand the power of bucketing. Now I want to see the explain plan for the same join. Okay, here we are using non-bucketed to non-bucketed table join. So let me see the explain plan this time. We have turned off broadcast join. So this time let me see the explain plan. Here we can see now the first one. Here you can see, for the first data frame, it is scanning the data. Here you can see it's scanning the data. Then it is exchanging, it is shuffling the data. Then after that, it is sorting. And it is reusing. Here it's the same data set. That's why it is reusing. Here also it is performing the exchange. So there are 2 data frame. It has done. Then on top of that, it is it is performing merge operation. That is sort merge join. So this is what I explained in my previous video, sort merge join. So in case you have watched that video, you can understand this easily. Now, this is what is happening, when we are joining 2 non-bucketed tables in Spark. Now, in the next example, I am going to show, df3 that is non-bucketed table and df1 that is a bucketed table. Okay, now I want to display this result. The result is going to be same, but we can see the difference in the Spark UI. This time it is going to create only two jobs, one stage less, because here only one table TF3 that is non-bucketed. Okay, there would be exchange needed only on that side. Here you can see. Now this is a non-bucketed table. It is scanning and also it is exchanging. Then it is, the other one, it's a bucketed table. It is not exchanging. It is directly scanning. Why? Because this table is already pre-shuffled and pre-sorted. That's the reason. Simply it is scanning the data. That's it. It is not performing shuffle, exchange. It's not performing sort. But coming to non-bucketed table, it is performing a shuffle and also on top of that it is performing sort. Then based on the result, it is merging. Okay, this is the difference. So here, we are performing extra operations like shuffle and sort. So it is going to consume more time. Actually, this is coming from non-bucketed table, that is DF3. And this is coming from DF1, which is already pre-shuffled and pre-sorted. I hope you understood the difference. Now let's see the explain plan also for this one. So in the explain plan, here we can see, the first one, this is bucketed table. So here it is, it is doing file scan, but after that you cannot see exchange anywhere. It is not shuffling the data. But coming to the second one, second data frame, non-bucketed table, here you can see there is a exchange. Hash partitioning, it is exchanging, then based on that it is sorting, then finally it is merging. Okay, this is the difference. So this data frame, it's a simple scan from the storage. Now here in this example, I have written the data to DBFS location. So just a table scan, that's it. Then here it has to perform the table scan and also data shuffle. So this is the difference. I hope you understood. And coming to the last example, this time I'm going to join bucketed table to bucketed table. Okay, df1 that is also bucketed, df2 that is also bucketed. So let me display. It has created two jobs. Let us look at the DAG created in Spark UI. Here you can see it's only one stage. It's scanning the data. Bucketed one, the other data frame, that again it is just a scanning, and there is no exchange, there is no sort. Okay, simply it is scanning the data, then immediately it started merging because data is already pre-shuffled and pre-sorted. Okay, this is the advantage of bucketing. So let me look at the explain plan also. Here you can see it is scanning the first data frame and there is no exchange. Coming to the second one, again it is scanning, but there is no exchange at all. Finally, it started merging using sort merge join. So this is how bucketing works. Whenever we are bucketing and the number of buckets are same for two data frames, then what happens is it will avoid shuffle and sorting. So the performance will be very quicker. Maybe in this example, I have executed with 3 combination. Here you cannot see the difference in the performance, but when we are working with very complex real-time data, definitely we can see big difference in these 3 different types of joins. I hope you understood bucketing and how to apply in your project, how it works internally. I hope you understood that concept. Hope you enjoyed this video. If you like the content of this video, please like and comment in the channel. Also, don't forget to subscribe and click on the bell button. Thank you.